I'm happy to introduce my colleague, Avril Styrman, a great philosopher and who is also been really looking deeply into the dynamic universe model and working also in the area on philosophy of science. And he, of course, will be telling us about the unifying power as nexus of explanatory virtues. Ole hyvä.
Oh, thank you. Kiitos. Thank you, everybody, for being here. We have a lot of material to cover, so let's get on. Now, let's start with big name. I've learned this from Paavo. Always start with the big name. So Thomas Kuhn, he said that every individual choice between competing theories depends on a mixture of objective and subjective factors or of shared and individual criteria. The goal here is to systematize the objective criteria or virtues for the sake of facilitating the recognition of good theories and the recognition of subjective factors in theory choice. Specifically, the goal is to systematize the explanatory virtues of fundamental empirical theories or descriptive models in physics, chemistry, etc. This project is very old as philosophy, and it has evolved from loosely related lists of virtues into more comprehensive systematizations, and these overlap with coherential accounts of epistemic justification. I present a unificatory model of explanatory virtues, abbreviated as UM. It's a taxonomy of virtues, that is specifically an irregular acyclic graph, so one virtue may belong to several categories. And in addition, it complements the taxonomy with varying types of relations between the classified virtues, so it can be seen as an informal axiomatic system. So first, the taxonomy that distinguishes the central virtue classes and their overall relations is presented, and then I construct the explanatory virtues one step at a time and look at some of their relations. So let's look at the top level categories. Ethical virtues, their criteria for good scientific conduct. Formal virtues, criteria for well-formulated theory. Then explanatory virtues indicate how well it explains and predicts. And pragmatic virtues indicate how applicable and understandable the theory is. Aesthetic virtues indicate whether a person thinks that the theory is beautiful. And then some of their relations. So the theory's satisfaction of ethical and formal virtues are a prerequisite for its or essential for its reliable evaluation of its explanatory virtues. So we cannot reliably evaluate its explanatory virtues unless it satisfies these ethical and formal virtues. And its pragmatic virtues are partially derivative from its explanatory virtues, and they are also a basis of assessing the viability of aesthetic judgments about the theory. So explanatory virtues are in the center of everything, and then unifying power is the center of explanatory virtues. So we can say that unity is the center of theoretical virtues. Then a little more detailed look about ethical virtues. So its text is small because I want to fit it all in one slide. For instance, basically we can formulate ethical virtues in a way that violations of all other virtues must be acknowledged openly, not hidden. For instance, anomalous data for T should be openly acknowledged as an evidential vice, not suppressing it in silence, or not manipulating it to fit the theory. Then formal virtues, these are basically the virtues or criteria for a classical axiomatic system then applied to a physical theory. Concepts and principles should be openly and clearly defined, and syntactic simplicity is preferable. Everything should be derived from the basic principles, although additional hypotheses may be postulated and approximations are legitimate. But it's still preferable to derive everything from the principle. Nobody would object that. Okay, then explanatory virtues. The theory has great unity. It achieves a great scope or high evidentiality, accuracy, and depth for several phenomena by applying a simple ontology and remaining internally consistent. Its unity increases over time as it yields also successful science-based technology. It's externally coherent, it's consistent with and has strong explanatory relations with other good theories, and the focal set of theories has a great unity. And then pragmatic virtues, it's labor-saving and convenient, and it makes phenomena understandable. And then aesthetic virtues. So we can see the dual nature of aesthetic virtues, that we can say that the aesthetic simplicity, it may or may not align with objectively measured simplicity and unity. Okay. And then the relations again. What are the relations of the classes? So it's quite apparent that the satisfaction of the ethical virtues and some formal virtues is a prerequisite for its reliable evaluation of explanatory virtues. And we can see that pragmatic virtues are partially derivative from its explanatory formal virtues. For instance, its internal consistency, great depth, and simplicity enhance its usability and understandability, as well as a tool for making phenomena understandable. And then explanatory virtues are basis of assessing the viability of aesthetic judgments. And the dual nature again, somebody might say that, okay, I like the theory, it's beautiful, but then if it has some meaning outside personal emotions, expression of personal emotions, then it's kind of verifiable, then it has a truth value, and we can assess its truth value by measuring the theory's unity. And now we build up virtues one step at a time. Start with accuracy, depth, internal consistency, that are commonly, I refer to them as evidential virtues. That's evidence. So accuracy, closer its predictions are to the empirical data about a phenomenon, the more accurate it is regarding the phenomenon, and the greater its depth for the phenomenon, the more extensively it specifies the causes of the phenomenon. And the greater its depth, the more likely it is to yield accurate predictions about the phenomenon, and the more understandable it makes it. So these are quite significant relations. That theories with great depth tend to produce accurate predictions is bad news for instrumentalism, like the shut up and calculate attitude, or the view that predictions are all that matters. For if predictions do matter, then the explanations that produce them also matter, should matter. In this light, we can ask, is instrumentalism in fact even internally consistent? Is it? This is a good question to ask from the instrumentalists. And back to the main course. Explanatory depth is measured for one phenomenon at a time, as is the case with accuracy 2. The theory's depth is 0 when it provides no causal explanation for the phenomenon. For instance, it's just the mathematical description of the phenomenon. And then depth is 1 when it meets the minimum requirement for causal adequacy that specifies the causal factors. For instance, as an example, combustion is as an explanation of burning. Everybody knows this. Burning is a chemical reaction where fuel reacts with an oxidant and produces heat. So there are lots of causal factors: fuel type, oxidant, temperature, pressure, catalyst, products. So we can conclude that combustion is causally adequate, whereas the phlogiston theory fails to specify even the basic causal factors. Therefore, it might be quite poor in producing predictions. So we are thus far. There are criteria for assessing explanatory depth above 1. One of them is the length of the causal history chain of the phenomenon to be explained. You can illustrate it that if you explain only the direct cause of the phenomenon, then the length is 1. But if you explain the causes of C, then length is 2, and so forth. The longer the chain, the better it is for controlling and preventing and understanding the phenomenon. And another criterion is the degree of the variability of conditions under which it remains valid. It can be also called the causal counterfactual account. And next, we proceed into total evidentiality. It's also called scope or generality. That is the sum of the theory's predictive accuracies and depths for all phenomena in its domain. In the basic setting, it is defined as the number of different kinds of phenomena for which the theory's accuracy and depth meet some threshold, like the current accuracy, like the accuracy of current data and the depth of a standard theory. It's just said that it explains n phenomena. It explains 10 phenomena, then it's like a supposed implicitly it meets some threshold of accuracy and depth. If the basic setting is too cumbersome, we may change it. We may make it this function for theory's evidentiality for one phenomenon to vary over real numbers from 0 to 1, or remain open-ended, whatever we want to do. Now, relatedly, in fact, Petri also already touched this topic, that we might never face competing fundamental theories with exactly equal evidentialities. And this is because we are dealing with research programs at different stages of development. And a paradigmatic theory characteristically has immense resources, whereas its rivals might be left with no resources at all. Martin Lopez Corredera calls this the Matthew effect. Or the rival theories are, in any case, very underdeveloped. So practically, the paradigm rival evaluation is by necessity limited to only some central phenomena in their domain, like with the case with dynamic universe, because there's no thousands of mathematicians who have worked with it 1,000 or 100 years, sorry. So that's why we must evaluate only some phenomena it does explain. So the practical goal in evaluating competing theories is to identify good theories based on their explanations of few phenomena only, so that we would understand whether they deserve more funding. And back to the main track. So we have accuracy, depth, and then total evidentiality defined in terms of accuracy and depth. Then we move on to internal consistency. Theory's components, predictions, explanations do not contradict one another. Its inconsistency signals non-understandability and shallow depth for some or all phenomena in its domain, and also hinders the evolution of its accuracy. This is because if nature is non-contradictory, as most people assume, then an inconsistent theory is false and cannot have great depth. And McMullin points out that this likely shows at some point in its predictions. And it cannot be, an inconsistent theory cannot be thoroughly understood. It's a pragmatic vice. Popper and Niinoloto consider this requirement obvious. There are some people who hold these instrumentalist positions that maintain that science can tolerate inconsistency, because we have seen many useful theories or sets of pointedly grouped propositions that are inconsistent, and we can apply them in deriving results. That's fine, but still inconsistency is a relevant aim, although we can grapple with these inconsistent theories that, after all, hinder the evolution of its accuracy. The good old Popper points out that a mere instrument for prediction cannot be falsified, and instrumentalism can be used to rescue a theory that is threatened by contradictions. Now we move on to ontological and syntactic simplicity. The theory's ontological complexity or weight denotes its total weight of its content. It comprises all of its hypotheses, including its fundamental and primitive principles and laws, hypothetical entities, properties, and also its empirical parameters, like particle masses that are not predicted but measured. So the smaller ontological weight, the greater ontological simplicity, and the greater ontological weight, the smaller its ontological simplicity. So we can now distinguish ontological weight from a theory's syntactic weight, which denotes the complexity of its formulation. For instance, we can say that the contemporary formulation of Maxwell's equations describes the same content in a simpler way than Maxwell's original formulation. And then to unifying power, also called the relative simplicity, economy, parsimony, Occam's razor. It's the ratio of the theory's total evidentiality to its ontological weight. It favors the ontologically simplest of equally evidential theories or versions of the same theory. Unity is high when evidentiality is great and ontological weight is small. So given two equally evidential theories or versions of the same theory, the ontological simpler has greater unity. It has sources, for instance, in Kaila, Eino Kaila, and lots of formulations conform it, like this one from Gerhard Schurz. And we can see the relational priority order of evidentiality and ontological weight. The maximization of total evidentiality has the highest priority, while minimization of ontological weight has the second highest priority. What this means that the highest priority of evidentiality is not after all absolute, for the minimization of the ontological weight constrains it. Thus, to qualify as a relevant alternative, the theory should not be ontologically extravagantly complex. As Nicholas Maxwell points out, that if theories were assessed impartially with respect to evidence, physics would be overwhelmed by an infinite swamp of empirically successful but horribly disunified theories. So, thus, a mere conjunction of primitive formulas would not be accepted, even if it were more accurate than the standard theory. On the other hand, the minimal ontological weight is relevant only when it's coupled with high evidentiality, whereas simple theory lacking evidentiality appears to have no value. Similarly, consistency is an evidential and pragmatic virtue only as a property of an evidential theory. The priority order of internal explanatory virtues need not extend further because unity is the ratio of the highest and second highest priority virtues. And moreover, a theory's explanatory evolution can be described in terms of the evolution of unity. However, eventually we must also evaluate theory's contextual virtuousness. First, we look at theory's evolution over time. So I'll just skim through the rest of this. Time is running out. Basically, we can define the theory's diachronic virtues if its unity increases over time. And then we can represent this in terms of different graphs. We can represent different situations. Here is time, data, and evidentiality on x-axis. And here is the unity is the black line, and ontological weight is the dotted line or dashed line. All right, we can see here that it's a successful theory, increasing unity. Here is a theory, temporary drop because of an parameter that was then discovered, then a rise. And here's a vicious, here's absolutely great development because it just rises directly. And here is orderly accommodation because unity stays constant and ontological weight rises. So we could go through this graph describes the evolution of the continental drift theory. Then here we see orderly accommodation, just more hypotheses, unity remains constant. And here we have discovery of a hypothetical entity again. First some success, then a hypothetical entity, then its discovery. Like in the case of discovery of Neptune. So we can apply unity in describing different developments. So that's the point here. And then external coherence, that's the last. External coherence, also called universal coherence, contextual virtuousness, defined as the theory is consistent with other virtues theories and there are strong explanatory relations between them. The point here is that unity incorporates these two effects, consistency and explanatory relations. So we have unity for one theory, simple, its ratio of its evidentiality and ontological weight. Exactly similarly, we have several theories, their unity is a ratio of their evidentiality and ontological weight. So first we incorporate consistency, so it doesn't contradict other theories. You can suppose that we have an internally consistent set of theories. Each theory is internally consistent and all consistent with all other theories in the set, contrasted with a set of theories of which some are inconsistent. Like similarly with a single theory, an inconsistency in a set of theories indicates a lower evidentiality and therefore lower unity, because evidentiality is a part of unity. That's quite straightforward. And the last point, explanatory relations between these theories signal lower ontological weight and greater explanatory depth, and therefore greater unity. it happens in a total Nagelian reduction. For instance, when Kepler's theory was directly reduced to Newtonian mechanics, never mind the formulas. And it happens also with partial reductions or explanatory relations. Like, what are they called? They're called interfield theories and intermediate explanatory relations. For instance, when biochemistry provided the physical nature of a repressor that was postulated in genetics, in this case, the total ontological weight of these two fields jointly understood decreased and their evidentiality increased, and therefore their unity increased. And I've confirmed this from a biology professor. Yes. And we can identify lots of these cases. So the point here is that unity is the nexus of explanatory virtues. Thank you.
Okay, I think we can have there are some questions. Peter? Okay, we have a few questions. So who want to go first? Let's.
On the microphone.
Okay. Fausto? Let's Fausto.
I just wanted to ask you how precisely you want to define that E of T part of your definition.
Come again.
You have something called E of T. Maybe I missed one slide. How is that defined?
Oh.
Yeah, the one that appears in almost all slides.
Like here, E.
Yeah.
Yes, it's evidentiality of theory 1 there.
Yeah, what is it?
Oh, it means that it's here. Let's get back. It means that it's a sum of the accuracies and depths of the theory in hand, like here. It is the sum of the theory's predictive accuracies and explanatory depths for all phenomena in its domain.
So this takes into account the correctness of explanations.
It takes the account of predictive accuracies and then explanatory depths.
Aha, also the depths.
Okay, yes.
Okay, but then an inconsistent theory seems to have, let's say, almost maximal evidentiality, I would say, because it will give you lots of wrong explanations that can proceed for arbitrarily deep levels.
Well, I don't. Maybe I didn't understand, but typically you have an empirical theory, then you measure how well its predictions conform to reality. So not just any theory produces them. And then you measure how deeply it explains the phenomenon. So that's also, it's all measurable. That's why they're called evidential. So it's not just any logical theory produces them.
Maybe we'll ask you.
Yes.
Let's have a mic and then we have and Peter.
Well, I think I can manage to have a mic. Can people hear all right? Okay. Yes. Sorry. I'm sorry. I hope you won't be offended. I'm going to push back quite hard on what you said. I think if you take all of this very elegant methodological generality around Kuhn and train it on some concrete case studies, I can think of at least one example, I think I can probably think of a few more, where you had theories which were embedded, theoretical proposals which were well developed, which were embedded inside quite mature research programs, which seemed to have all these virtues of evidentiality and particularly of unificatory power, which turned out to be complete wide alleys. Supersymmetry is one that seems to come to mind. I don't know how other people would react to that. And so the whole supersymmetric program in as an extension of the standard model clearly promised a very considerable unificatory power. It was a very natural extension of a mature research program, and it seemed to meet all of your criteria for total evidentiality and internal consistency, but it led nowhere at all. It hasn't hitherto. So I'm just wondering, if you take all of this machinery and actually train it on some real-world case studies, how well does it really hold up?
Well, I don't know very much about supersymmetry, but I have the idea that it's very complex, highly complex, syntactically and ontologically, all the dimensions, and my picture was that it didn't like even fare well empirically, I thought.
Well, no, it certainly didn't fare well empirically. That was my point. Yeah.
Yeah. So if it didn't fare well empirically, then it can't be. Then it couldn't have had a great explanatory depth.
I see. So this is an ex post thing. Okay, I see.
You had one?
Yeah, just on the relations to experiments, because you mentioned getting results that correspond. But some theories, the strength is that they propose experiments. They guide the experimental work. Is that included in one of these parameters?
So the theory suggests new tests.
Yeah, because it provokes new questions that, for experimentalists. I mean, that's very much how.
Well, that exact one criterion, if I had to now immediately fit it in the taxonomy, I would put it maybe in pragmatic virtues. At least the pragmatic virtue, easy to test, might be extended by facilitates creating new tests.
But no, it doesn't facilitate. It kind of provokes an experimental investigation because it kind of leads to a new physics, for instance, in the physics case. So it's not really pragmatic. It's kind of asking questions. It's a theory that asks questions, new questions in a way, from experiments.
Well, maybe it could be placed as a diachronic virtue. Like here, it says theory's unity increases over time and it yields successful science-based technology. It could be extended by it prompts new questions that are then like advance the field of study. It could be placed there.
Okay, thank you.
So we have Eetu. Let's keep them short now because we have to move on.
Yes, so I would have a sort of pattern of questions in regards to certain topics, but I will try to condense it to just one simple question. I am not sure if the ethical virtues and formal virtues combine into explanatory virtues or are sort of necessitate explanatory virtues by any other way than including some type of factivity. I think that the sort of ethical virtues that do sort of necessitate explanatory virtues are expressed in the examples, for example, making an analysis jump in derivation of prediction of the data type of thing, which sort of, I think, has implied factivity in there. So what is the sort of role of if we take a sort of look at this argument in this structure, what is the role of factivity in this explanation? And is it really true that ethical virtues are sort of grounding in grounding the explanation?
Well, all this means is that, for instance, if there's lots of anomalies, like dozens of anomalies, then the proponent of the theory doesn't care for them. Just thinks that, okay, the theory is free of anomalies, although that's not the truth. So that would be an ethical vice, hiding an evidential vice. So in that sense, we need to be honest. Honest. It's just like be honest. So the theory is, it's easier to evaluate the theory. Does that sound plausible?
Okay, let's have a final question from you.
One question more, which comes back to one previous question, and it is how well this kind of grand picture actually fits to real progress and advancement in physics. It's very streamlined, and probably if you look safely from the distant view, take a view on physics, for example, you can find out these kind of aspects which define how the theory progress. But if you look on more details, supersymmetry might be a one, but even more simple case could be the case of Sommerfeld's model and Schrödinger's models. You know that Sommerfeld's model very nicely explained hyperfine structure of hydrogen, but Schrödinger's model didn't. But yet Schrödinger's model was more favored for the physicist in comparison to Sommerfeld's model. If you just look on the explanatory virtues in regard of the given context, Sommerfeld's model was much better. How do you can incorporate this kind of micro-level evolutions in physical theory in this kind of grand picture?
Okay, so in the first slide, I talked about this subjective factors and then objective factors. So yes, there are always, it's a great deal. As you told just 2 days ago, physicists are very conservative. So the train keeps on moving, whatever happens. Look at the standard cosmology. Like it has supporters whose faith doesn't fade away, even in the face of whatever crisis comes. So yes, all this have to be taken into account. But that's more like how it should be. It's like a normative suggestion. And I had it, but I took lots of stuff away. So I earlier had a strong emphasis. No, it's just a normative suggestion of how, if things were this way, and if physicists would have more eye on this than, for instance, tradition, then would the progress rate of science be faster? Maybe.
Thanks, I agree, and I appreciate these kind of big pictures because it helps to see many things which are hidden in the ordinary daily work in doing physics. Okay.
Let's thank Avril.
Thank you.